Now, having just told you that I have this nice simple quartic fourth order polynomial I need to solve, you probably are wanting me to solve it for you. And this is where I stop and tell you about one of the difficulties of teaching an introductory chemistry course is that, yes, I could allow you to pull out your fancy calculator and stick the numbers in and hit go, and it would tell you x. And knowing x, you'd be able to solve the rest of the problem. But I also know that you would have not the foggiest notion of what had happened along the way. And given the fact that very often in courses like this, professors are predisposed against letting you use fancy calculators if it keeps you from being able to think, it's entirely possible you'll be asked to solve this problem without a calculator. So how do you do it? Well, here are some possibilities. As I said, you can use your fancy calculator, or you can do what I did before there were fancy calculators. Believe it or not, there was this kind of trial and error method where what you would do is you would take a value of x and you would stick it into your simple little equation, and you would find the answer. So I stick it into my little equation, and remember, once I stick in my value of of x, if it can end up equaling 3.8, that's what x is. So you stick in the number, I don't know, 1, crank, 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 comes out at 1,000,000. Oops, that was nowhere near. Maybe I'll stick in a half. So you stick in a half, crank, 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 comes out at 46. Oh, it's getting closer. That's better, it's getting closer. And then you stick in another value of x. And you do this iterative method to get closer and closer and closer. You're sitting here listening to this, and you can't believe I'm saying this is how people do this. But in fact, this is what people did before they were calculators. They would just back substitute in a result until they finally got x close enough to where it would generate 3.8 for the answer. Well, I'm not going to be able to make you do that, but I'm also not going to let you use a fancy calculator. One of the other things I can possibly make you do is to simply look at the correct answers. Remember, I'm giving you multiple choices, A, B, C, and D. Only one of those four must be x. So if you can take one of those four values and stick it in, back calculate, then guess what? You will know if that particular value, letter B, was the right answer, that that was the correct one. So this kind of back substitution, not of these random numbers you generate, but rather of problems that are sitting on a multiple choice test, is a legitimate way to be able to work that kind of problem in that kind of testing environment. And of course, the final and most sophisticated way to make you do this is not to have you know the numbers at all, but rather have you have an intuitive feel for the chemical system. So that I'll say to you, you know, I don't really care if you know exactly how much nitrogen there is, or how much ammonia, or how much hydrogen. I just want to know the relative amounts of these. Which one is present in largest amounts? Which one is present in smallest amounts? That's something we're actually going to spend a lot of time developing. It's not the quantitative skills of just being able to plug numbers into a calculator, but actually having an intuitive sense about what the chemistry is that's taking place, and therefore how much stuff happens to actually be present at equilibrium. What stuff is significant and what stuff is not. In fact, when we get to acid-base chemistry, when we get to solubility, that's pretty much all I'm ever going to be asking you is, what are the important species present? Not, what exactly is the concentration?